Like we saw with even functions, we can understand odd functions algebraically as well. To do so, we'll first look at how both reflecting across the x-axis and reflecting across the y-axis work together. We'll start with a generic graph, y equals f of x. The graph of y equals f of negative x is the graph of y equals f of x reflected across the y-axis. If we now reflect y equals f of negative x, our new graph, across the x-axis, we get the negative of this function, which is y equals negative f of negative x. But notice, the graph of y equals negative f of negative x is the graph of y equals f of x, our original function, rotated around the origin. Since the graph of y equals negative f of negative x is the graph of y equals f of x rotated around the origin, and we define that a function y equals f of x is odd if it remains the same when we rotate around the origin, we can conclude that a function is odd if negative f of negative x, the rotated function, equals f of x, the original function.